Hi, everyone. This is a big caveat because I'm never quite sure how things come across in conference brochures, but this is aimed at people who have either a very light understanding of Docker or have no idea at all. Hello, everyone. I'm Ciaran. I'm involved in a bunch of open source projects like PHP Spec and Behat and Cucumber. I do a lot of coaching and training for teams in agile stuff, how to get better at delivering. I also do architecture and stuff. I work for a few companies. Half my time at the moment is spent with Rove. So if you want a group of experienced developers who know what they're doing to help you with a project, talk to me and I'll send you to the people who know how to do sales. I have ADHD, and I mention that because I got diagnosed as an adult, and a contributing thing was someone at a conference talking about it. So if you want to talk about that at the social or something, find me. What's Docker for? There's a sort of constant problem in software development of everything works great, all the tests pass, then you deploy it to some other environment and everything breaks terribly. And I think that's been the case since the second computer was invented. And there are various strategies for dealing with it. Back in the day, we used to sort of have lots of tools that would set a server into a known state and sort of run them locally and hope that we're matching things up. An obvious way of doing this is a virtual machine. This is a VM I use to kind of sandbox a particular client's incredibly intrusive VM. But it's a pain because I'm running macOS and I'm running a virtual machine that's macOS, and it's using loads of resources because there's a VM kind of has complete isolation. The advantage of a VM is you can run a different operating system inside your operating system. But when you're running the same operating system, there's no efficiencies, there's no shared components. I've got to have a whole separate macOS install eating up my disk. The basic system components are running inside the VM and outside the VM, that kind of thing. So, going back 10 years, there's a lot of usage of VMs for local desktops, tools like Vagrant. People are still using them very efficiently. But there's a performance overhead, there's a resource usage overhead, and I've never been that happy with the various tools that people use to ship VMs around, and ship your VM to production always seemed a bit weird and bulky. So there's a sort of gap in the market for a better way. And what Docker's really about is, don't ignore the blob of text, but this idea of OS-level virtualization, where if you're virtualizing an operating system inside an operating system, you can probably share a lot of stuff that already exists. And really, what Docker and containers do is they sort of don't virtualize at all. You run a process, and you isolate it from the rest of the system, so you get a lot of the benefits of virtualization without this sort of clunky semi-emulation layer. A thing called C groups exists in Linux. You don't have to understand the image. But there's this idea that up here you can see you've got your real file system, and then certain processes can be run, isolated from the rest of the OS, and they see a file system that you kind of tailor to that C group. It's called a control group. That's a base building block in Linux. So a container isn't a VM. It's a Linux process that's running in an isolated way, and it's been given a file system. It's like Neo in the Matrix. He thinks he's in a city, but it's just all an illusion. That's kind of what your process is experiencing when it's running in a container. It thinks it's got access to the root of the disk. It thinks it can list all the other processes and there's no one else there. But it's all a lie. And the rough timeline was C group stuff was worked on for a few years and merged into Linux. 15 years ago, Docker started as a startup around that time with the idea of building tools atop this, make it easy to share containers, that kind of thing. And to their credit, 2015, most of the specs of the sort of foundational technologies of Docker got opened. So now you can write your own Docker-like tool with a compatibility with the spec to run containers, make images, that kind of thing. And also, 5 years ago, Docker started a long process of chipping out components from their monolith into open, reusable components. So you can write your own thing by implementing the specs, or you can use components that are off the shelf to build your own container runtime. I'm going to focus on all the Docker stuff, but just be aware there are lots of other projects that share varying amounts of code with Docker that do things differently. And it's all broadly compatible. So to get started, you need to install something. If you're a Linux user, you're probably going to have the fastest experience using Docker, and you just get it from your normal package manager. If you're on macOS or Windows, Docker Desktop is not a bad choice. There's lots of stuff where it will try to sell you extra services, but you just ignore it. And if you're on Windows, you can pretend to be a Linux user and apt install it in the Linux environment thing. So the problem here is I said it wasn't virtualization, but if you're a Mac or Windows user, you're using a virtual machine, but you're just using one virtual machine, and it's semi-hidden from you. So I'm running Docker Desktop for Mac. I never think about the VM, but there is one Linux VM being started, and all the containers are being run inside it, kind of in the background. And Windows Subsystem for Linux has a managed VM that it's using. WSLU2 has a managed VM that it's using. The architecture of Docker is pretty straightforward. We'll introduce a few concepts. So there's a service called Dockerd that's always running. And this is actually a criticism of Docker. You might not want to have a long-running service on your laptop just in case someone asks it to run a container. So some of the Docker alternatives are daemonless. But generally, there's a daemon running on a host machine that's going to do all the work. You have a client. So if I type Docker something, the binary then talks to the daemon and tells the daemon what it is I want to do. Most of the time, if you're a developer, these are the same machine, the client and the host, but conceptually they could be on different boxes. I could be running commands that are talking to a server somewhere else to tell it to run containers. Docker daemon maintains a store of images. Best way to think about an image at the moment is it's a file system. It's a snapshotted file system, something like a .iso file or a USB thumb drive, Plus it has some metadata to say when I run this image, what process should execute, which one process should execute. And there's this concept that images can be pushed from your host out to a registry, and you can pull them out from a registry so you can share images. So the image is it's kind of like a snapshotted disk. Let's think about it like that. The daemon is also responsible for managing running containers. So they're not VMs. I might say that too many times today. And don't even think of them like a sort of VM. A container is a process that's been given the files it needs to execute. So the image snapshot disk thing, when you run it, a process will run and it will become a container. And then the daemon is responsible for stopping, starting, creating containers. So here's how you run a container. If I type docker container run hello world, I get this message that hello world doesn't exist locally, and I'll see some sort of progress bar style downloading happening. And then hello world happens. The hello world script runs. So what's happened is I've asked to run hello world. The daemon's checked my image store and says I don't know what hello world is. It's pulled it from a registry, in this case the default Docker registry. And then it's launched a container based on that image. And that image is just a shell script that echoes hello world. Next time around, I won't see the pull mechanism. It will just say hello world. And like I said, on Linux, you will have native performance. This isn't a high performance, script. But it's just like running a process on Linux. On Mac and Windows, it's just like running a process in a VM. A note on the examples, when I show commands, I'm going to use the newer, sort of longer commands. The sort of namespace of the main Docker executable got a bit crammed. So all the things that are to do with containers can be prefixed with container. All the things that are to do with images can be prefixed with image, and so on. And if you ever want, a nice aspect of that is you can type something like Docker image help, and it'll show you all the things you can do with an image, rather than looking at a big list of stuff. So I've tried to use the long forms of commands. Also, any flags I'm showing, I'm trying to show like the long format, but they nearly all have like a single letter thing. I just think that's bad for presentations. So I can list which containers are running, and there aren't any running. If I ask for all the containers, I actually see that my hello world script, the script ended after it outputted the string, but it's sitting in this kind of stopped state. I could start it again and it would echo the string again. For one-off scripts, that's not that useful to have them stopped, but for something like a web server, you might want to be able to run it for a bit and then stop it, and then sort of resume it, restart it. There's lots of detail you get here. The main thing I want to show is that containers have a unique ID. They also have a sort of generated friendly name, or you can set a name. And I quite often get people send me a screenshot because my surname is in the dictionary that's used to generate this. So you'll get like idiotic McNulty, and something's like Harson, that's Ciaran. And that's because someone added all these computer pioneers to the dictionary. I don't know if I'm related to this lady, but she apparently invented the subroutine. And you'll see lots of computer pioneer names in the list. So if I've got a stopped container, I can delete it. Remember, all of these things are going through the daemon. I'm asking the daemon to do it, and then the daemon's doing it. And then I can list, there's nothing there. And for a one-off run of something, you can add this RM flag, which means instead of stopping at the end of execution, the container will be completely deleted. So if you're running your PHP unit tests and you forget to put RM, your list of stopped containers will slowly grow. It's not a problem, but it'll annoy you one day when you look at it and realize there's loads of junk. A gotcha when people are running interactive containers, and I think this comes from thinking about them as VMs, is they think, well, I'm going to run Ubuntu, and nothing happens. The reason is that when you think about starting Ubuntu, you sort of think about booting a desktop, and you think about millions of processes are going to start at the same time, and the scheduler is going to be responsible for time switching. The Ubuntu Docker image has the process that's been nominated to be run when you run Ubuntu is bash, and bash only. And bash doesn't like talking to non-human users, or at least it doesn't sit around waiting for input. If I add these flags to say, this is an interactive terminal, someone's typing, and also please, I'm cool with colors and stuff, it will launch a bash session in the container. But I want to emphasize that's because the Ubuntu image is configured to run bash as its main script, its entry point. So I can poke around this. It's like I'm logged into a Linux box now as root. And I can kind of poke around and look, and it looks like Ubuntu. And I would be forgiven for thinking that means lots of services are running. But if I PS, it's just me there. I'm the only one in there. The bash session that I ran is the only thing running. And it can subshell and run PS and stuff. But there isn't the normal stuff you would expect to be running if you did that on an Ubuntu box. But all the file system's there. It's a complete Ubuntu file system. The only way you can tell you're in a container, really, is if you look at the kernel, it's the same Linux kernel in every container. It's shared between them. So the difference between Ubuntu and Debian is just the file system. You've got the same Linux kernel version running. So how do you name a Docker image? They have what's called a reference, and they look a bit like a URL. I mean, I guess they are a URL. And they come in three parts. Firstly, an image knows which registry it belongs to, and this is a bit different to something like Git. In Git, you tag something and then you decide where you're going to push it to. With a Docker image reference, the name of its sort of home registry is built in. It knows where it lives. So if you want to push to two places, you kind of have to tag it with both names. There's an idea of a repository. That's basically the path to a logical grouping of images. You'll find in public registries, like the one Docker runs, like the one AWS runs, maybe not, like the one GitHub runs, they tend to have a two-element name. That's just to make user permissions easier for them, a bit like how if you run your own Git server, the paths can be as deep as you want, but if you're using GitHub, it's going to be organization, project name. You'll see the similar sort of thing. So that's just like the path to the image. And then there's a tag. A specific image gets tagged. Like with Git, there's a sort of expectation that if I look at two different tags, the images will be somehow related. But there's nothing stopping you pushing completely different images to the same repository with different tags, in the same way you could have random stuff in your GitHub branches that have no relationship to each other, right? And the tags tend to be some sort of semantic versioning type format, but that's up to the maintainer. Now, before when I ran Hello World, I didn't have that big long string. I just had Hello World. So there is some defaulting, and this is Docker specific. So in the Docker tools, if you don't mention the registry, it looks at Docker Hub. So it's a very mild kind of vendor lock-in thing. Although Docker Hub has started charging you to go over the certain rate limit, which is a bit annoying. The repository if it's a single element name, the repository gets prefixed with library. Library is an organization on Docker Hub owned by Docker. And the default tag is latest. Latest just means the user didn't specify a tag. And it's just a default value. And you can see this. If I pull node, it tells me it's downloading Docker.io library node latest. I can explicitly pull the long version. It's the same thing as far as the tooling is concerned. So lots of registries exist. You might, if you've got an open source project, GitHub's container registry has quite decent limits on how many packages you're allowed to host for free. Amazon has a container registry. So if you're big on AWS, you'll probably be pushing your images into that. Or, one of my projects, we use GitLab, hosted GitLab, and that has a registry. So the CI server has it. Something to watch out for if you're, analogizing it to Git. In Git, we have a concept that branches point to different hashes over time, and tags always point to the same hash unless the maintainer's been naughty and retagged stuff. But in Docker land, images, you expect the tags to be retagged regularly, and so don't be surprised when that happens. So I looked, this is a few weeks ago, at PHP, the library PHP image, and you'll see that the latest version was 8.2.1 of PHP, and also the tag latest pointed to the same image. 8.2 pointed to the same image, and 8 pointed to the same image. The idea is if I'm saying PHP 8, and a new version comes out, I think we're now up to 8.2.3 a few days ago, So if I look now, latest would be pointing to a different image. 821 would still point to the same image. And if I've specified PHP 8, I'll always, every time I pull, I'll get the latest PHP 8 image. So you have to beware of stale tags. I constantly see people say, please run the latest PHP, and they're surprised it's an old PHP. It's because they're running the thing that was tagged as latest last time they pulled. It's like, I'm going to keep mentioning Git. It's like if you check out master on Git without fetching, you'll get the state that master was in last time you checked the repository, if you see what I mean. There's no magic. There are flags you can add to make it check. But I think the word latest makes people think there's going to be some mechanism that is ensuring it's latest, and there's no such mechanism. So if I pull, it'll actually say, oh yeah, I've got a new PHP latest now, and next time I run it, it's a newer version of PHP. And there's various ways of looking at what images you've got, and if you want to image inspect an image, you get a huge amount of JSON come back that tells you all about it and how it got built and what's in it and who made it and that sort of thing. So let's build one. Most of the time you'll be building an image for your project. And the way you build an image is in Docker, is writing a Docker file. So the builder, which is called BuildKit, for the last 6 years it's been BuildKit, and it's slowly become the default builder. I ask it to build, and it looks for a Docker file that looks like this, and it turns that into an image. Oops. So the first line, it tells me, I want all the layers from this public image. I want to start my image based on this public image, and then I want to copy a script into the image, and then I want to configure it so that script is the thing that runs when the container gets started. Like I override what the default script is. And earlier I said, think of an image as like an image snapshot. It's actually a set of layers. Each layer changes the file system slightly. So if you imagine you had loads of tar files, and you were going to untar them sequentially into the same folder, and later ones were going to overwrite the newer ones, that's kind of what the layered file system is like. The reason it's like that is that the way Docker and registries store images, they don't have to store the same layer twice. Let's talk about Git again. If you've got 1 million branches that all have a common ancestor, there's not lots of copies of that in your Git repository. So if I've built loads of images that extend PHP 8.2, my registry will have all the PHP 8.2 layers, and then it'll have only the bits I've added on the end for each tag. So let's look at some of the commands you can have in a Docker file. I should mention, actually, there are other projects that build images from things that aren't Docker files, because once the image is built, the source code is discarded. So there's some sort of cool tools for writing the syntax completely differently. So the add and copy instructions both take files and put them in the image. Remember, an image essentially an image is a file system with a bit of metadata about how to run it. So the thing we're mostly interested in is, how do I get files into here? There's two options. Add came first, copy came later. You mostly want to use copy. Add has magic, and that's why they added copy, to be less magic. The link flag, just put it in there. It makes it more efficient. So the top example, I'm copying 2 files into the image. That's pretty simple. So it will create a layer that says, add these 2 files in, and contain the files in the layer. This is quite cool, I can copy from a different image. So I can say, I want an image out of the composer public image, please. Can you copy it into my image? And while you're copying files, you can change ownership, you can change permissions on them as one operation. So if you need to copy it as a particular user or add an executable flag or that kind of stuff, you could do. Add is where the fun stuff happens. So add you can use to copy local files. But then if one of the magic things is triggered, you might be confused. So if I add a tar file, it gets untarred for me, which might not be intuitive. But I can add from a URL. That's nice. I can add a file at a remote location. And something that only got added quite recently, I can add a file from a Git repository. I can specify the branch and I can specify the file to copy, which is cool. And we'll talk about caching a bit later, but those two remote adds have good kind of caching built into the builder. So if I've built this before, the builder will do a head request to that URL and try and figure out if the zip file's changed. Similarly, it will keep the it'll keep the Git clone in its cache until it gets cleaned up. So next time I want to copy something from the same repository, it's got a local copy and it just has to check the local copy hasn't changed. So add and copy both explicitly bring files in. The other way files get into your container is you run a command that makes them. For instance, composer install is going to make a load of files. So every run command generates a new layer as well into your container. So in this case, it would generate a layer containing my vendor folder and probably some composer cache somewhere. And you want to minimize, when you're running, you often want to combine the commands together because in this example, I copy a script, I run the script, and then I delete a cache file because I don't want that cache to be in my final image. The problem is the way it's stored as layers. I'll have a layer that copies the script, a layer that runs the script and generates the big cache thing that I was trying to avoid. So I've got a big layer there. And then I've got a layer that deletes it afterwards. So you'll tend to see run commands squished together. So here I'm still doing the two same operations, but at the end of it, there's no cache, so the cache doesn't end up in the layer. But don't go too crazy micro-optimizing layers. You have to balance it with how shared they are with other images. So here we get 3 layers. That's the gist of how you build things. I'm going to talk a bit about caching because there's a lot of projects I've joined have complained about how long their builds take, and it seems like an underappreciated field. So layers are cached sequentially, so the order is really important, the order of your layers. So this is a very simple Docker file, and I've slightly cheated by not mentioning how Composer gets into it. But you imagine I'm going to take the public PHP image, copy everything into it, copy my code base into it, and then run Composer install. First time round, fetching the PHP image takes 10 seconds. Copying the files into the image is normally cheap, so a very, very short time. And the Composer install takes 20 seconds because networks, But the next time I do it, it's quite interesting. It does take half a second to check that the tag for PHP 8.2 hasn't changed. And then the copy takes 0 time. That's because it's not really 0 time, I've just got a fast laptop. It stats every file, it hashes every file. I can't remember. It checks if any files have changed, and if they haven't, it says, oh, I already know the layer that this would create. So I just use the layer I made last time. Similarly with the run, it sort of says, last time I ran, I had the same layer, and then I ran Composer install, and it generated this new layer. So I know what the answer is. I know that this file system plus run Composer install equals this new layer. That may or may not be what you want to happen. For instance, if it was a composer update, you would be using the cached composer update, if you see what I mean. If I run a command that echoes the date into a file, and then I build it again in a year's time, it'll use the cache, and I'll have the old date there. It's only going to redo it if the layer before changed, or if the command has been changed. Like I added a flag to composer. And so in this case, because I'm copying everything, if I touch a file, then it will run composer install again, because the builder doesn't know which files affect the output of composer install. So it says if anything changed, then I have to assume that this instruction is going to produce a different result this time. So you end up ordering things around a bit. This is a sort of longer version of the same thing, but here I'm copying composer in. I'm copying the files composer cares about first, and then running composer install, and then I copy the rest of the files. So the difference is, if this, that doesn't work. If this, I can move. If I make new files in my code base, all of the stuff above it can be cached, and it will just have to run this command, which is my sort of warm cache command. So if I'm editing stuff, this copy has to run and this has to run again. And it's only if I edit one of these files, if I edit the composer JSON, next time I build, this will hash to a new hash. It won't know what the result of running composer install will be, so this will execute again, and it goes downwards. So you have to sort of think about what order of operations you want, and think about which files are going to change more often, and put them towards the end. And things that never change, like the apt install, some dependency, can go at the top. And if you've got your cache set up correctly, a lot of these things will take 0 time in sort of day-to-day. And this isn't a talk about optimizing builds, but another important thing to look at is multiple stages. So this is an example where we've got 2 from statements. What this means is I can ask the builder to build either one by giving a flag and giving the name of the stage, final, or composer installer. Or by default, we'll build the last one. And I can copy things between stages. So the graph for this ends up like this. And an interesting thing about it is that BuildKit, the builder, will parallelize these builds if you've got enough cores, or if you've given Docker enough cores. So it will pull the PHP image. In the left-hand one, it will pull the composer image and install composer. In parallel, it's copying all my source code into the final image. And then it copies composer JSON, composer.lock. It runs composer install, and the final one will have blocked. So if it's got to the point where it wants to copy from vendor, it'll block there, and then it'll copy the vendor folder over into the final one and run. So the output of this is going to be slightly different to this one, in that composer was only copied into the composer installer image, so the final result won't have composer in it. I'm not as worried about any temporary files that composer install have made, because I didn't copy those over. And there's some interesting differences in how cache invalidation will affect it. In general, BuildKit builds, you can have loads of these things and everything getting copied around. And BuildKit's kind of building a graph of it and figuring out which things need to be built to get your final result. That was a diversion. So some more stuff you can do when you're building an image. Arg is how you parameterize your build. You don't want to you might want to build multiple PHP versions, for instance, if you're doing a kind of matrix-style CI. You might want to, I couldn't think of a good example, so I've said the code base needs to know the Git hash for some reason. I have worked on a code base where that was in the requests and responses in dev mode, so it's not too obscure. So build arguments have to be passed in explicitly. They can have defaults, and they change your build. Env is sort of a related command that sets an environment variable in the resulting container. So if you want your container to have certain environment variables that your script is interested in, you can set them in the build. You can also change the working directory and the user. So if you do that in the middle of a build instructions, it basically changes the current working directory, changes who is running the commands and stuff. And then at the end, whatever the last worker and user were is the working directory of the finished image and the user that things will run as in the finished image. Containers mostly run as root by default. And lastly, so all of that was to do with what files are going to be in the image. The last thing you have to configure is the entry point and the command, which together tell Docker what to run when a container is started from that image. Which one process is going to be the winner? Is this a web server? Is this a shell script? Is it a database? The reason it's split into two is that the entry point is, well, you just imagine they're concatenated together. In the PHP image, the entry point is user bin PHP. And then the command is, whatever you type after PHP to give it flags. And you can override that when you run them. So at this point, that's pretty much how you build an image. You write a Docker file, you commit it to your repository, you write a command that whirs away and spits out an image. You specify a tag for the image, so you have something to call it. And then you'll have the image locally in your Docker registry. When we run an image, we want to be able to control it. We want to be able to change stuff at runtime. You don't want everything to be hard-coded into an image. So one thing you want to do as a developer is a bind mount. Docker has a whole concept of volumes, which at runtime they can be attached to containers and shared between containers if you want containers to share things. The thing you'll mostly be doing, it's called a bind mount, is you're mounting a file from your host machine into a specific place in the application. So in this example, I'm taking the generic PHP image. I'm mounting my code base into it at /app, and I'm setting my working directory to /app. And then I can run PHP unit, and it runs. So those files aren't in the image. It's sort of there's the file system that's been built into the image, and then you're over-mounting whatever you want from whatever location you want on your host file. This isn't something you do in production, but when you're working on a code base, especially PHP, where we don't have big compile steps, you probably want to mount your working folder into the container, so when you edit a file and then go and refresh your browser, it's been updated in the container as well. For shipping to production, you want to be baking the files into the container, into the image. The other way that you configure containers is through environment variables. So any sort of runtime config, URLs it needs, things that are going to be different between boxes, you tend to detect it from environment variables. If I try and run MySQL, which is the official MySQL image, Docker calls all the library / stuff official images, but it means Docker official. So if someone says the official PHP image, they mean the one that Docker says is the official image. It doesn't mean it was generated by the PHP maintainers particularly. So the MySQL thing has some environment variables that have to be set. So I can run it with env, set what the root password is, and then I have a working MySQL server running in a container. And I know the password. I'm sure you can imagine why you don't hard code the password into a database container. Another thing you'll want to do is to access that container. So containers are isolated and you can't easily connect to them. It defaults to running in a bridge network, and you can publish ports from the container to your local host. So here I'm publishing the MySQL port to the same port on my local machine, and I can connect to MySQL just using localhost and that port. I put protocol equals TCP here because MySQL does an annoying thing. If you have a MySQL server already running on your machine, and you say, I'd like to connect to localhost on this socket, please, it sees localhost and it says, oh, he doesn't mean that. He wants to connect to the MySQL server actually on his host through a file socket, and I'm not going to mention I've done that, and he'll spend half a day figuring it out. More than once, because he forgets. So that's it. That's running containers. We've seen building images, running containers from them. That's a creepy picture. The layer above that is orchestration. So if you were typing Docker run this container, and then you have to remember to then run the other container, because we don't just deal with one process at a time. We want to have a PHP app server, a web server, a worker, a database. Running loads of Docker commands and hooking them up together would get painful. There's a whole networking side where you have to create a network and then make sure your containers are in the same network so they can see each other. So Compose is a layer above this that deals in services. It's very commonly used in dev and CI. Docker sort of tried to make it happen in production, and it didn't really work out, and Kubernetes sort of won quite significantly. But it's almost a no-brainer for, I want to add something quickly to my project that will let me spin up all these things together in a coordinated way, and all the tools will use it. It started as a Python project. It got adopted by Docker. Again, like these things tend to happen, the config spec moved to an open standard, which is it's good that that happens. And a couple of years ago, it was all rewritten in Go. It used to be a bit annoying because when you installed it, you'd get all of Python from your package manager as well, and now it's just a binary that you can run. That's not a diss on Python. I don't think PHP is a good language to write command line tools for people who aren't PHP developers in as well. And the main thing with Docker Compose is that it's a YAML config that just specifies what containers are going to start. If we need to build any, how are they going to be built? And then how are they hooked together? So it's the kind of thing you could do as a makefile with all those Docker run commands we've been looking at, but it's config, declarative config. So the main thing to think about is services. I'm going to show a sort of typical PHP app. So I might have an application server and a web server. That's annoying that we have to do that still. There are solutions to not having two separate things. One solution is use Apache, but often you'll tend to have an Nginx and a FPM service. FPM would look something like this. So we're not going to build all of these things, but the PHP image is something we're going to build. So the YAML config, just the build section, pretty much maps over to the flags I would have passed when I typed docker build x build. It's the same stuff. So I say what the build context is. I say where the Docker file is. I can pass in a build argument. And then there's some runtime configuration as well. When you bring this up, mount my development version of this project into the right place in the container. Pretty simple. For Nginx, I'm not going to build that. I'm just going to use a public Nginx image. You might decide to start building your own Nginx image if you reach the limits of how the configuration stuff that's been built into it. Or there's fancy stuff you can do in production with fast CGI ingress things, so you might not even be using Nginx. So in this case, there's no build section because I'm not going to build it. Instead, I nominate an image. I say, use this image. And they tend to be pretty user-friendly, these images. So the Nginx has a location that you can drop templated config files into. So you have a sort of template of an Nginx config, and then it interpolates in the environment variables into that file and then uses it to boot Nginx. So I can plug in. I would have used these environment variables in my config file, and then I can sort of change them at runtime. And the important thing there is that we're pointing the fast CGI thing from Nginx to app, which is the other service. So Compose takes care of this DNS, so app now points to that other container. If you want longer URLs, there's a thing you can add. And I expose the ports locally, and I do a sort of user-friendly thing where if the developer already has something running on port 80, they can override it to a different port. I want a database. Similarly, MySQL has a thing that lets you set the password. It also has a folder you can drop config files into. It additionally has a nice thing where there's a folder that you can put .sql files into that will get loaded in at boot if you want to seed your database that way. RabbitMQ as well, why not? All of these, I'm not building my own implementation, I'm just configuring public images that someone else maintains. And at the end of all that, I have to go back to my app and give it some connection details for the database and the queue. Again, I'm using the service name, so the keys in the YAML are the names of the boxes, and you can call it something .local if you feel that's less confusing. And the assumption is my PHP application is going to read the environment variables for its config. One last thing I can do, I might want to have something that's processing the queue, and instead of building a completely separate image, I can use a fancy YAML anchor. That's a YAML feature, not a Docker Compose feature, to say, yeah, this service is the same as that one, except instead of being an FPM server, it's going to run this command. So I write all this YAML, run it, and what I see is a load of build output. I see it pull all the images that I've asked for from the public, and then it brings up all the containers. And at some point later, I can connect to port 80 and my system's running. And there's a worker processing the queue, and the logs start appearing in my terminal. That's it. That's the Compose workflow. Last thing I wanted to talk about was how you might, that was for the developer, local developer, how would you then apply that into a CI pipeline? And here's a way of doing it. Compose lets you specify more than one file to read. So if I set this compose file environment variable, Compose will take the sort of main one that we wrote for the devs, and then we can add stuff to it that is CI specific. Depending on how shared your runner is, you might want to set the Compose project. I won't explain what that is. It'll collide if you've got loads of parallel builds on the same box. You want it to have a unique ID. And then I can write some YAML that adds a couple of things. I want to add an image name to my PHP image, the one that just had a build. I want to add an image name, and that image name is going to be unique to this pipeline, or unique to the Git commit, or something like that. That's where it's going to get pushed to. And there's some cache to and cache from stuff that you should explore. So if you've got short running sort of on-demand workers, the build caching stuff we looked at earlier, the cache won't be populated, but there are some mechanisms for sharing the cache. You can push it to a registry. You can stuff it into GitHub Actions. There's a few things you could do. Because that's the ideal scenario, is if you trigger a build, the Docker image build should take almost 0 time. It just needs to check if anything's changed. Ideally, things will be cached. And so for a simplified build pipeline, the first step will be build all the images. So it will push a tag like this that's unique to the build. It'll build the image and then tag it in the registry with an ID that's unique to the build. So even if you've got a big fan out of lots of different things you're doing in CI, do one build. Don't build the image loads of times, it's a waste. The validate steps, the middle layer, they can pull, because they've got the same ID, they'll automatically get the same image. You might not need that if your runners aren't like all completely separate, but most of the time, I'm trying to do these 3 things in parallel. So they pull the images, it should be very quick, and then they run whatever test they want to run. And then to distribute it, after a tag, or maybe you always distribute passing builds, there isn't a nice way to do it just in Compose, but basically you use Docker tag to copy the image from the tag that is the unique build to the registry it's actually going to go to for delivery with a version ID or something. So you might push version 1.0.0 after everything built successfully. So you temporarily store a tag that is, the hash of the CI run, and at the end you tag that with a release, or you push it to main, or whatever you want to do. And in general, a lot of the ways production stuff will be configured, or one of the ways you can configure production stuff, which isn't in the scope of the talk, is that it's just constantly looking for when a new image is published, and there will be some rules. Whenever a new FPM image appears, spin up a container off of it, slowly move traffic over. That's all production stuff that I try not to get too involved with, because I don't want to carry a phone around. So hopefully that's the whole pipeline. We saw how some of the fundamental concepts, we saw how you run someone else's image, we saw how you build your own images, and hopefully you've got an idea of how you tie it all together with YAML and get it coherent. So thank you very much. I need to know if we have time for questions.
Yeah, I think we've got about 10 minutes if we need it.
Oh, that's great then.
So, any questions? I'll run to you with the mic if you don't mind, so everyone can hear the question.
This is always the scary bit.
Hi, great talk, thank you very much. I just have a question about copying, if this is in scope, copying tokens to containers to authenticate with things like GitHub repositories. Yeah. What's the best practice for that?
Don't use an argument. Don't use arguments, because they're visible in the image afterwards. There's a thing called a build secret that is probably the best way to do it. There's actually 2 times you might want a secret, actually. There's runtime secrets. So it might be a secret that only needs to be used when the application's running and might change over time. And there's a mechanism called secrets that I didn't kind of go into, where you can either set an environment variable in the container, or you can mount files into a specific location in the container. So you might want to, so you have your secrets in some secrets manager, and then when the containers run, a file in a specific location has the secret. That's the sort of runtime stuff. And there's an equivalent called build secrets, which is for secrets you need during the build, like authenticating with the Git repository, and it's a very similar mechanism. So it's just some extra flags at the CLI or in the YAML.
Any other questions? Jesse's one behind you there.
Oh, no.
Thank you for the talk. I saw on some of your slides you had a reference to Alpine images. So they are like stripped down, like smaller versions. Would you say it's a good practice to use them? Because I know there is some debate around it.
Is Derek in the room? If you ask Derek Rettons about it, he'll tell you why Alpine's terrible. I think there's not as much of a margin in it anymore. A lot of the public images, for instance, PHP, you can ask for the Alpine version or the Debian version. The Debian one is very stripped down now. And I think people's obsession with the size of an image maybe isn't as important, but I've certainly used Alpine for stuff. I keep meaning to check out ChainGuard as well, which is an even more stripped down Alpine-y thing. In general, I guess you want to have as few files in a container as possible, mostly I would say for security reasons, rather than image size reasons. But you kind of want to know what's in there and is it affected by any vulnerabilities and that kind of thing. So I don't have a strong opinion about using Alpine. I do.
Thank you.
Yeah.
Okay, I think we had one more over here as well.
Hey.
Hi. So a question about bind mounts. So we use bind mounts in development, and on larger projects, they tend to get very slow on macOS. Do you have any tips on that?
Minimize the amount of stuff. The reason for that is that on Linux, bind mounts there's no overhead. On Docker Desktop for Mac, you are mounting the file into a VM, into the Linux VM, and then that's getting bind mounted in, and it's the first step that's the problem. So Desktop for Mac has 3 different mechanisms for it. None are great, and there are competitors that do it a bit better. Can't remember the names of any of them now, but there are other products that have slightly more efficient mounting options. It's annoying. You can often just take out a lot of the mounts for the files you're not working on. It's especially a problem in PHP. So one of the reasons it's painful for us is that you mount loads of files into the container and they're all used at runtime for your local dev. You're not op-caching it. If you think about a Java workflow, they output a .jar and there's one file sort of running the application, whereas we're constantly including PHP files, so it's much more escalated for the interpreted languages. And I think most of the developers are Go developers and don't have that pain. So they don't care so much about it. I know some people use mutagen, which kind of, it's okay, but you need to add lots of extra config just for the Mac users. Just have some patience is what I say.
All right, thanks.
When you were building the PHP image, you specified 8.2.
Mm-hmm. Yeah.
Why? So that 8.2 tag keep changing presumably. Why would you pick 8.2 over say 8.2.1? Or does it not really matter?
It's a very good question actually. So what's going to happen here is that every time PHP is released, my base image is going to change and my cache will get invalidated. But as long as I'm regularly pulling PHP 8.2, I'm going to get the latest version with fixes in. So I think it's more of a question for, I think if you're pinning to a minor version, which I have done on projects, you need to make sure there's another mechanism in place that's going to tell you when that needs to be updated, something like one of those bots, Renovate bot, that's going to say, hey, you're using a PHP version that's behind and make a pull request for you and stuff. So you can have that explicit control. You can also pin to a SHA. So you can say 8.2 at, and then a hash, and it will always get that hash. It kind of ignores the tag in that case and just uses the hash. There is some stuff in the pipeline where you can have, I don't know if it's been merged yet or just proposed. There's an idea you can have a separate file that resolves all the references into hashes, and you'll be able to input that into build kit sort of separately during the build. So you can say, during this build, treat all of these short versions as this hash. Or at least tell me if it's not true anymore. That sort of thing. There's a whole software bill of materials feature that's been added where you get a huge audit of everything that's in your image that you can compare to security advisories and things.
Okay, anything from the left-hand side of the room? No, we're good. Everyone wants their lunch, I think. Okay, thank you again to Ciaran.
All right, thanks everyone.